Hello and welcome to SYMMETRIC Academy the Intellects on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. In this video, we are looking at June 2022 Advanced Level Mathematics Paper 2, Question 6, Roman 2. So before I continue, I would like you to subscribe to the channel and activate the notification bell to not miss any of our videos subsequently uploaded. So the question reads, let n be the set of natural numbers. A relation R is defined on n by AB relates to CD as B as D all over B is equals to C all over A. Show that the relation is an equivalent relation. So show that R is an equivalent relation. So the solution for an equivalent relation, for a relation to be equivalent, it has to be reflexive, symmetric, and transitive. Not reflexive or symmetric or transitive, because if one condition is not attained, then the relation is said to be not equivalent. So it has to be reflexive, symmetric, and transitive, so that it should be equivalent. So let's check the conditions. The first one is reflexivity. So we prove that for every, this symbol here stands for every AB, CD in N, AB related to CD implies that AB is related to AB, or CD relates to CD. It is both the case, so both cases are the same. Now, to prove that AB relates to AB, we replace. Now we are seeing here that this is AB relates to CD, and here we have AB relates to AB. It means that A has taken the place of C and B has taken the place of D. So we are just replacing. Everywhere I see C in the relation, I put A, and then everywhere I see D in the relation, I replace it by B. So B all over B is 1, A all over A is 1, and it implies that 1 is equals to 1. So we can conclude that our relation R is reflexive. Now the next property is symmetry. We prove that for every AB, CD in N, AB relates to CD implies that CD relates to AB. So that is just a symmetry. So we first of all write our relation AB relates to CD as D all over B equals to C all over A, and we call this one equation 1. Okay, so want to arrive to, go to the next slide. Want to arrive to CD relates to AB, and CD relates to AB is simply B all over D equals to C all over, that is equals to A all over C. Look at, we are seeing here that in our previous relation here we have AB and CD here, but now in our relation I want to arrive to, we have both CD and AB. So CD relates AB. It means that we'll replace, I'm just going to interchange. That is, the place where I see A I put C, and the place where I put C I put A. So that's how I'm going to proceed. So we want to arrive to that. Okay, so we now take to arrive to this equation, or to arrive to this condition here, we have to take the reciprocal on both sides of equation 1, because we have posed our equation 1 to be this. Taking the reciprocal meaning that we are going to reverse, because we could still say reversing equation 1. So if you reverse equation 1, we are going to clearly see that we have B all over D equals to A all over C, and which is our relation CD relates to AB. And then we can conclude that our relation is said to be symmetric, or our relation is symmetric. Now the next property and the last property is the transitivity. For the transitivity, we prove that for every, now we now include another two sets. We prove that for every AB, CD, EF element of N, AB relates to CD and CD relates to EF, should imply that AB relates to EF. So we include what? An external set of factor which is EF. So we say that AB, if AB relates CD and CD relates EF, then AB should relate EF. So let's go ahead. The relation AB relates CD is D all over B equals to C all over A, and we'll call this one equation 1. And then the relation now CD relates EF is, now we see here that what CD has taken the place of AB and EF has taken the place of CD there. So It means that the place where I see D, I replace by F, like here. Where I see B, I'll replace by D. Look at it, has interchanged that position, or it has changed that position. And then where I see C, I replace by E, as you see. Now where I see C, I replace now by, where I see A, I replace by C, because A and C has changed position, B and D has changed position, C has changed position with E, and then D has changed position with F. I will call this one equation 2. Now we want to arrive to this relation here. So first of all, write our relation. AB relates to EF implies that we have AB all over, that is, we have F all over B should be equals to E all over A. So that's why we have to arrive here. Now we are seeing, to arrive here we need to use this equation 1 and equation 2, because to arrive here we use both equation 1 because we only have one equation 2. Here we need to use the two equations to arrive. So we are seeing here that on this relation I am not seeing D and I am not seeing C, so I need to do my best to eliminate D and C from this my relation here, from this my two equation here, and then simplify to have this. So that's how we do a proof. You identify what is not present and then you remove it from the other part of the expression. So if I say equation 1 times equation 2, I will get what? dB, d all over b times, that is d all over b times f all over d, is equals to c all over a times e on f, that is e on c. So we are going to realize that d will cancel d and c will cancel c. So we left with f all over b is equals to a all over, that is equals to e all over a, and which is effectively our relation AB relates to EF, like here. So we can conclude that hence the relation R is transitive. So now the relation is reflexive, symmetric and transitive, there is an equivalent relation. So we conclude, we say since the relation is reflexive, symmetric and transitive, then it is an equivalent relation. So guys, we have come to the end of this video, and if the video was interesting to you, I invite you to subscribe and share the video, and you can also comment. If you've arrived to the end of the video, it means that you're a serious student, and if you arrive to the end, then I invite you to tap the comment section and say, in science, consistency is the key, and in science, consistency is really the key.